Welcome all to today's lecture. The subject I am covering in my lecture series is microprocessor. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. I am covering first unit, and the topics that I am going to teach today are addressing modes and interrupts. What is addressing mode? This is a very common term being used in all the microprocessors and controllers. So what does this term mean? Addressing means that we are addressing something, and mode means the way of addressing. So the addressing that we are talking about in this topic is about the operands. How the data is presented through the operands in an instruction that is known as the addressing mode. So the different ways of specifying the location of an operand in an instruction, it is termed as addressing mode. For example, there may be a case when the operand is present in a register. So we are giving the name of the register in the instruction. There may be another way of presenting the number through the direct number itself. That is, in the instruction we are specifying the number itself. That is the operand. So that is another way of addressing. There may be a way when the operand is present at some location, at some memory location, and we are giving the address of that particular memory location in our instruction. So this may be some other way. So in this way, all these addressing modes, that is all the ways of presenting the operands inside an instruction, this can be classified into these types. What can be these types? Implied or implicit addressing mode, stack addressing mode, immediate addressing mode, direct, indirect, register direct, register indirect, relative addressing mode, indexed addressing mode, base register addressing mode. This is different from the register addressing mode. Auto increment addressing mode is another form of addressing mode, and similarly auto decrement is there. Now let's go into details what are these addressing modes used for. So first of all, let's talk about the very basic addressing mode, that is implied addressing mode, or we can call it as implicit addressing mode. In this addressing mode, there is no need of specifying the operands. That is, the definition of the instruction itself specifies the operands implicitly. For example, complement accumulator. In various microprocessors, this is the instruction for this operation, that is CMA. So CMA is not carrying any operand. It is the only opcode in this case. So we are not explicitly defining or specifying any operand in this case. So these types of addressing modes are known as implicit or implied addressing mode, where the presence of operand is already implied. So no need to specify operands in this case. So CMA is the perfect example of such addressing mode. Now another addressing mode, that is stack addressing mode. Yes, before moving further, we can have another example for implied itself, that is NOP, no operation. NOP is another example. So in this way, we can have a look at various examples from this category. Now stack addressing mode. In this addressing mode, the operand is contained at the top of the stack. So this is another addressing mode in which the operand is lying at the top of the stack, and from the specification of the operand in the instruction, we can get the idea that the operand is lying at the top of the stack. Now immediate addressing mode. Immediate means the data is immediately specified in the instruction. So in this addressing mode, the operand is specified in the instruction explicitly. Means that in this case there is no presence of register, there is not any presence of memory address, but the operand is itself present in the instruction. That is known as the immediate addressing mode. Why immediate? Because there is no need of accessing any register, there is no need of accessing any memory, since immediately the data is available. For example, this add 10, it will increment the value of the value stored in the accumulator by 10. So, whatever is present in the accumulator, here the 10 will be added to that value. So, this instruction will give the result of this operation a plus 10, and the result will be stored in accumulator itself. So, this is how the immediate value is mentioned in the instruction itself. Now, let us see another example. There are certain microprocessors or the controllers which have the different way of specifying the immediate data. So, there is in some controllers, this is the way of specifying the immediate value, that is using hash. So, this example, move R hash to 20, this initializes the register R. R is some register. So, this operation will initialize the register R to a constant value 20. So, this is the way of copying the value 20, that is the immediate value, to the register R. So, this is the immediate addressing mode. Now, we come to the next, that is direct addressing mode. Here, the address field of the instruction contains the effective address of the operand. Only one reference to memory is required to fetch the operand. It is called absolute addressing mode. So, that is the direct addressing mode or the absolute addressing mode is one and the same thing. So, in this case, this is direct, means there is a direct access to the operand through the memory address. So, only one reference of the memory needs to be specified in the operand, and this needs to be fetched. So, in this case, suppose the value is stored at the location X. So, accumulator will be adding the value to the suppose we are giving this instruction. So, add and some memory location. So, whatever will be the value at this memory location, that will be added to the accumulator, and the data will and the result will be stored in the accumulator again. So, this is how this direct addressing mode works. Now, we talk about the indirect addressing mode. In this case, the address field of the instruction specifies the address of the memory location that contains the effective address of the operand. So, whatever the value of the operand is, that will act as the memory location of the operand. So, whatever is present in the operand, whatever we as a programmer, we are having at the operand location, that will be treated as the memory address, and the content that will be present at that memory address, that is our operand. So, on that the operation is going to be done. So, here it contains the effective address of the operand. Two references to the memory are required to fetch the operand. So, one reference is the value that is present at the operand that is given in the instruction, and that value will be treated as a memory address. So, again it has to be that memory location has to be fetched for the exact operand value. In the case of register direct addressing mode, in this addressing mode, the operand is contained in the register set. The address field of the instruction refers to the CPU register that contains the operand. No reference to the memory is required. This is very important. So, here the location of the operand is the register, that is CPU register. Suppose this is the instruction add R, it will increment the value stored in the accumulator by the content of register R. So, in this way, the value of this register, whatever is present is in this register, will be acting as one of the operands and will be added to the accumulator, and the result of this operation will be stored in the accumulator. Now, next is register indirect addressing mode. In this addressing mode, the address field of the instruction refers to the CPU register and that contains the effective address. So, here the value, whatever value is present in the given register that will be treated as a memory address, and whatever contents are present at that memory location, that will be your operand. So, in this way, this is somewhat indirect, register indirect addressing mode. Now, when we talk about the relative addressing mode, in this addressing mode, the effective address of the operand is obtained by adding the contents of program counter with the address part of the instruction. So, in this addressing mode, one of the register that will be containing the memory address will be your program counter, and another will be the address part that is specified in the instruction. So, effective address is equal to contents of the program counter and address part of the instruction. So, in this way, this addressing mode is known as the relative addressing mode, in which one of the operand is the program counter contents and another one is the address. So, the addition of these two things that are given in the instruction, that will be treated as the effective address. So, this is known as the relative addressing mode. When we talk about indexed addressing mode, here the effective address, instead of the program counter, the contents of the index registers will be treated as one of the operands, and another will be the address part that is given in the instruction itself. So, the addition of both these, the content of the index register and the address part that is given in the instruction, that will be treated as the effective address. Now, this is known as the indexed addressing mode. Earlier, it was known as the relative addressing mode. Since we are using the index register, this addressing mode is known as the indexed addressing mode. Now, when we talk about the base register addressing mode, the effective address is obtained by adding the contents of base register with the address part of the instruction. So, here the only difference is the presence of base register. So, in this mode, that is the base register addressing mode, one of the operands is present in the base register, that is the memory address is specified by the base register. So, that's why this is known as the base register addressing mode. Now, when we talk about the auto increment addressing mode, this addressing mode is a special case of register indirect addressing mode. Effective address, that is the content of register. Here, after accessing the operand, the contents of the register is automatically incremented by step size D. That is, the step size D depends on the size of the operand accessed. Only one reference to memory is required to fetch the operand. In the case of auto increment addressing mode, what happens is that as we are accessing the operand, then the content of the register will, from where the operand has been accessed, that the size will increase by size, that is the location of the register will be incremented by the size D, which is known as the step size and depends on the size of the operand. So, suppose first of all the memory was present as 3020. So, if the size is 2 bytes, then the 3022, another location will be 3022. In this way, the step size becomes 2 in this case. So, the contents of the register is automatically incremented by step size 2. The effective address is known as is equal to the content of register. So, this is known as auto increment addressing mode. Similarly, in auto decrement addressing mode, again it is the special case of register indirect addressing mode. So, what was happening in register indirect addressing mode? That whatever the value is present in the register, that will be treated as a memory address, and the contents which are present at that memory address, that will be your operand. So this is a special case. What is special in this? That effective address of the operand will be the content of registers minus step size. So in this addressing mode, first of all, the contents of register is decremented by step size d. It depends that what is the size of the processor. Then step size d depends on the size of the operand accessed. After decrementing, the operand is read. Only one reference to memory is required in this case, since the operand is being read only once. Only one memory is accessed here. So in this way, this completes our addressing modes. So here we have discussed the typical addressing modes that are present in the processors or the controllers. It is not necessary that all these memory addressing modes are present in any processor or controller. Maybe few of them are present in the basic controllers or processors, and in advanced processors and controllers, maybe all of them are present. So this depends upon the processor or the controller that we are talking about. Basically, from these mentioned here, these are very common. That is implied addressing mode, immediate addressing mode, direct addressing mode, indirect, register direct. These are very basic addressing mode. These five addressing modes are present in any of the microcontroller or processor. Now let's have a look at the applications of these addressing modes. When we talk about the immediate addressing mode, that this is used to initialize the registers to the constant value. In the direct addressing mode and the register direct addressing mode, it is used to access the static data and to implement the variables. Indirect addressing mode and register indirect addressing mode, it is used to implement the pointers, because the pointers are the memory locations that store the address of another variable. So that's why these are used in the pointers. Or to pass the array as the parameter, because array name is the base address and the pointer is needed to point the address. Now, the relative addressing mode is used for program relocation at the runtime, that is for position independent code, or to change the normal sequence of execution of instructions. For branch type instructions, since it directly updates the program counter. So, relative addressing mode is used in these cases. The index addressing mode is used for array implementation or for the records implementation. Base register addressing mode is used for writing relocatable code, that is for relocation of program in the memory even at runtime, or for handling the recursive procedures. So in the base, since we are using the base register, so this scheme becomes very effective for relocation of the codes or for handling the recursive codes. Auto increment and the auto decrement are used for implementing the loop, since we know that in the loop we need to increase or decrease certain variables. So, or for stepping through the arrays in the loop, or for implementing a stack as the push and pop. Now, yet another topic, important topic, is interrupts. Interrupt is what? Interrupt is a signal emitted by the hardware or the software, and which stops the normal processing of the being done inside a microprocessor, and that is a process or an event which needs immediate attention, that triggers through the hardware or the software and terminates or stops the ongoing procedure. So this is the way how the interrupt occurs. It alerts the processor to a high priority process requiring interruption of the current working process. So in this case, the current working process stops and the interrupt sequence is being executed, or we can say it starts executing. In input-output devices, one of the bus control lines is dedicated for this purpose, and it is called interrupt service routine. So what is interrupt service routine? That whatever the code, whatever the program that is being written for the execution of the interrupt, suppose some trigger has been done externally through the hardware or the software, which terminates our ongoing normal procedure. So that is interrupt. Now, when interrupt arrives in through some pin or through the software and it aborts our normal processing, what happens? Some other processing has to be done, some other procedure has to be followed. That series of procedures, that code is termed as interrupt service routine. So, what is interrupt service routine? It is a program that is executed whenever the interrupt arrives. So, when a device raises an interrupt at, let's say, process I is the interrupt process, the processor first completes the execution of the instruction I. So, then it loads the program counter with the address of first instruction of the ISR. So, what is happening is that suppose we are at some instruction I, here the interrupt occurs. So, what is happening? Immediately the program counter is loaded with the address of the first instruction of ISR. When interrupt occurs, here must be some ISR routine related to the interrupt. So, this is the first most location of the starting of the interrupt service routine, and the program counter is loaded with the address of that ISR. So, before loading, the program counter with the is loaded with the address of this first address of ISR. The address of the interrupted instruction is moved to the temporary location. So, when the interrupt occurs here, we are at this address. So, next address which has to be executed after the ISR completes, that has to be saved somewhere to a temporary location. So, basically it is stored in the stack. Therefore, after handling the interrupt, the processor can continue with the process I plus 1. So, this is process I plus 1 here, and after the completion of the ISR in between, this working has to be resumed from this location. So, this address needs to be stored somewhere at some temporary location. So, generally this temporary location is the stack in most of the processors and controllers. So, while the processor is handling the interrupts, it must inform the device that its request has been recognized so that it stops sending the interrupt request signal. Also, saving the registers so that interrupted process can be restored in the future, as I told you. So, it increases the delay between the time an interrupt is received and the start of the execution of ISR. Since whenever the ISR arrives, the program counter has to be loaded with the first address of the ISR routine. And at the same time, the address of the next instruction which has to be executed after the ISR completes, that has to be stored somewhere at some temporary location. So, during this processes, that saving of the loading of the PC with this address and saving of this address at some temporary location, this requires certain time, and that is known as the interrupt latency. So, there is a time gap where when the interrupt is received and when the execution of the interrupt starts. So, this is known as the interrupt latency. So, in further lectures, I will explain that what are the types of the interrupts. Suppose the interrupts have been broadly classified as software and hardware interrupts. They may also be classified as vectored and non-vectored. So, in this way, I will explain the interrupts in details. So, by now, that is all for the day. Thank you.